Hello and welcome. Today we want to handle series of powers of natural numbers. Our first example or our first instance, we have a series that takes the form 1 plus 2 plus 3 plus 4 plus, and that series is infinite, which is equals to summation, or rather taking the sum from 1 to n over number r. And then our second instance, we have a series of square numbers, plus 2 squared plus 3 squared plus 4 squared plus, the series is more of infinite. We want to show that it's equal to n into n plus 1 to n plus 1 and everything divided by 6. And then thirdly, we have 1 cubed plus 2 cubed plus 3 cubed plus, you can say 4 cubed plus, and the series is continuous. We are saying it's the same as getting the sum of r, and then this sum is squared, which is the same as n into n plus 1 over 2 squared. And now this means that this sum is equals to n into n plus 1 over 2. Those are the three instances that we want to prove, and we're going to use the method of difference. We have two methods. We have the induction method, but our key method here is the method of differences. The method of differences for step 2 and step 3, but for step 1 we're going to solve it directly. Now we're going to have, we are saying that to get, we have the formula of getting the Sn, or the sum of numbers in an AP, is n over 2a plus n minus 1 d. We have a formula there, but now we have an AP here, and our AP, the first equation was of this form. Now this tells us that this AP, our first term is 1, our common difference is 1. We want to get the formula for the sum, and it has n terms. We're going to say the number of terms is n. Our number of terms is n. So we're saying that our sum of numbers in that AP is equals to 2 times 1 plus n minus 1 d. But d is 1. Now this one becomes n over 2 into 2 plus n minus 1. When we expand, we're going to have n over 2 plus n minus 1. That gives us, when we simplify, we're going to have n over 2 into n plus 1, which is the same as n into n plus 1 over 2. And now we have seen, we have proven our first formula for that AP. We're getting our desired value, which is n into n plus 1 over 2, which is quite simple. And now we're moving to our next, which is here, Roman 2. We want to prove this sum of the sum of numbers in an AP, but now it's square numbers. So we want to use the formula of difference. You can use induction, you can use any other formula. Now you're going to our Roman 2. our AP looks like this. We have 1 squared plus 2 squared plus 3 squared. Our sequence is not countable, or rather it's infinite. Now for this sequence, we're going to use an identity. In order to prove using the difference method, we're going to use an identity, and the identity is n plus 1 cubed. N plus 1 cubed is our identity. We're going to expand n plus 1 cubed, and as for my case, I'm going to use the binomial method, whereby we have a power n b power 0 plus a power n minus 1 b to power 1, in that manner. So in this case, I'm going to have n cubed 1 power 0 plus n squared 1 power 1 plus n power 1 1 power 2 plus n power 0 1 power 3. And then after that, I'm going to substitute back by my coefficients, and my coefficients are 1 3 3 1. So I'm going to have n cubed plus 3n squared plus 3n plus 1. And the use of binomial expansion makes it easier for you to expand rather than guessing about what your value should be. And now we are decreasing. We are saying that, for instance, if we have this equation and we keep subtracting 1, at the end we're going to end up with 3, 2 and 1. So our value here, n plus 1 cubed, is going to decrease by 1. So in our next step, we're going to replace n with n minus 1. So we are replacing n with n minus 1. We're going to replace n with n minus 1. But now, before we replace n with n minus 1, we need to come up with an identity. You can see we have n, these ones are to power 3. Now that means we are going to collect like terms and get n plus 1 cubed minus n cubed is equals to 3n squared plus 3n plus 1. This is the identity you are going to use, and decreasing it step by step. Now we are replacing n by n minus 1 in this equation on the left hand side and also on the right hand side. Now we are going to have n cubed minus n minus 1 cubed, because if you decrease this by 1, we're going to be left with n, and if you decrease this by 1, we're going to be left with n minus 1 is equals to 3 into, we're substituting here n minus 1, we have n minus 1 squared plus 3 into n minus 1 plus 1. Again, because we have said we are decreasing up to a point we're going to get 3, 2 and 1, because any big number, as big as it is, it can always decrease in a certain order until you get a 0. Again, we are decreasing. We're going to have, if n minus 1 decreases by 1, we're going to have n minus 2. Now here it becomes n minus 1 cubed minus n minus 2 cubed. That gives us 3 into n minus 2 squared plus 3 into n minus 2 plus 1. And you know it's continuing in that manner, so we're going to have n minus 2 cubed minus n minus 3 cubed is giving us 3 into n minus 3 squared plus 3 into n minus 3 plus 1. Definitely, if you continue decreasing these things, at some point you're going to get to 3, 2, 1 in that manner. So we are saying 3 cubed minus 2 cubed will eventually give you 3 times 3 squared plus 3, not 3 but now 2, plus 3. So we're going to delete that. We're going to have 3 minus 2 squared plus 3 times 2 plus 1. This one is times. And now we're going to have 2 cubed minus 1 cubed, which will give us 3 times 1 squared plus 3 times 1 plus 1. What happens here? We're going to add this side. So we want to add the left hand side. So when we add the left hand side, we are starting here n plus 1. This one is starting here n plus 1 cubed minus n cubed. When you add to n cubed minus n minus 1 cubed up to this point, everything else is going to cancel out, as you can see. And now we're going to be left with only 2 terms. And now those 2 terms, after adding on your left, we're going to have n plus 1 cubed and then negative 1 cubed. And now when you're adding on your right, you're going to start here. So you can realize all of the coefficients have 3. Now 3 is a common factor. We are saying 3 into n squared plus n minus 1 squared plus n minus 2 squared plus all the way to 2 squared plus 1 squared plus, we come back, pick the coefficients of n. All of them have 3. So we have 3 into n plus n minus 1 plus n minus 2 plus, going in that manner, plus 2 plus 1 plus, we have 1 plus 1 plus 1 plus 1 n times. So we have n into 1. After getting that, now you come back and look at the equation, how it behaves. You will find that this one is the sum. You're going to have 3, the sum of squares from 1 to n, plus the other part here is 3, the sum of r's, and then plus n. And on the left hand side, we have to expand. We're going to get n cubed plus 3n squared plus 3n plus 1 minus 1. Now 1 minus 1 will cancel out and give us a 0. And now our area of interest is this r cubed. So we're going to say 3 from 1 to n r squared plus 3 into, this summation you already know is n into n plus 1 over 2 plus n. This one gives us is equal to n cubed plus 3n squared plus 3n. But now we have to make whatever we want here a subject. So we're going to multiply through by 2 to remove this fraction here. Now we are multiplying everything by 2. On the other hand, we are also multiplying by 2. So we have 2n cubed plus 6n squared plus 6n is equals to 6 sum of r squared plus 3n into n plus 1 plus 2n. Now we collect the like terms. We're going to leave 6r squared alone, so making it the subject, 6 the sum of r squared. It's going to give us 2n cubed plus this value here can be simplified. We're going to get 6 summation of r squared plus 3n squared plus 3n plus 2n. So 3n squared, if it's subtracted from 6n, it gives us plus 3n squared plus, this is 5n, if subtract here you get n. And now after getting n, we want to make that sum the subject, so we divide through by 6. And now we're going to get that our sum from 1 to n, you can see here our n is a common term. We have n into 2n squared plus 3n plus 1 over 6. If you factorize our brackets, we're going to get n into n plus 1 to n plus 1, and now everything is over 6. And now in our third part, we are going to check on 1 squared, 1 cubed plus 2 cubed plus 3 cubed plus, and going to prove that it's going to give us r squared squared. So stay with us and follow to be able to catch the last part. Thank you and bye.